Hello everybody. Today I'm going to show you how to run and perform a flow simulation in SolidWorks specifically for a CO2 car. At the very end, after we find and perform the flow simulation, I will show you how to calculate and find the drag coefficient using the link spreadsheet down below. It's a little bit more work, but it's very easy and it's much worth it because it allows you to understand how streamlined and aerodynamic your car is relative to other objects. So it's definitely worth it. It only takes about 5 more minutes. Let's jump right in. So once you have SolidWorks open, what you want to do is you want to create a new assembly. Once this is loading, you want to add your car in. So find and add your car into the assembly and click to add it into this area. Now you want to go to assembly and then insert components, and then you want to insert the wheel. And don't be too concerned about where this is placed for now, just get it in the general rough area. You can use your middle mouse wheel to rotate your car so you can get a little bit better of an understanding about where it's actually placed. Now, click Insert Components again, just go ahead and click Wheel, and when you insert your wheels on the other side of the car, click the rotate in the Y direction. You want to click that like twice. If you drew your car about a different axis than me, you might have to click a different button, but click the Y button if you drew it how I did. Now you can see this is pretty far off, so just like rotate and drag it until you get it generally close. I'm not a professional at this. Browse, open, rotate it, then place it roughly close to the desired location. Okay, so once we have all 4 of our wheels added, what we want to do next is click the mate button, and we're going to get the tires attached to the car. So go ahead, zoom in, click the inside of the axle, and then click the inside of the wheel, and then this will create a concentric mate. So go ahead and click OK. Now, next you want to click on the face that the axle is on, and then the face of the car that the axle is on. Then you want to click on the wheel itself, and then click that, and then this will create a coincident mate. So now they are touching, and go ahead and click OK. Now your back wheel is connected, so go ahead and do that for all 3 more of your wheels. Click confirm, check. This can be a slow and tedious process, unfortunately. Now, once you have all 4 wheels connected, now what you want to do is you want to save your assembly before you start your flow simulation. So save this to whatever folder or wherever you want to save this. I'm going to name this Epic CO2 car. Now, what you want to do is you're now ready to run your flow simulation. So go to SolidWorks add-in. If you don't have SolidWorks add-in as a bar right here, right click on the bar up here and go to go to tabs, and then you should see SolidWorks add-on. Click that check mark. Then you can click on this. Then you should see the flow simulation button. That will enable you to have this flow simulation here. I have a few extras, but you don't have to worry if your toolbar does not look exactly the same. So once you have flow simulation, click on that. Now we need to set up the flow simulation. So now you want to click on wizard, name this whatever you want. We name this flow sim. Go click next. Then don't change these are your constants. Click next again. Now click exclude internal space. Make sure that is checked, and then make sure your analysis type is set to external. Click next again. Now you want to add your gases that you're going to be running the fluid simulation with. So click gases and then air and then add. Now your flow simulation will be using air. Click next again. Now you want to use a roughness of 15 micrometers. I found from research online that it's roughly 15 micrometers 3D printed PLA. So for this specific CO2 car, it's going to be printed with PLA. So go ahead and use a roughness of 15 micrometers, and that'll make your flow simulation even more accurate. Leave that adiabatic wall. We are not concerned with the temperature change in our plastic as it's going down the track. That's not what we're concerned. That's not what we're concerned in right now. So click next again. And now this is a part where you want to make sure that your car is oriented in a certain direction. So depending on how you drew your car is how you're going to set up this flow simulation. So my car is pointing in the positive Z direction, going head on. So the air is going to be resisting our car moving. So what we want to do is about 20 meters a second is roughly how fast your car is potentially going to be moving. So go ahead and set this to -20 because it's going to be resisting. You'll see this little arrow show up right here. That's going to show the direction the air is flowing, and that makes sense for how our car is moving. So if you have your car oriented in another direction, you might need to change this, but for how I drew my car, -20 and the Z direction. Now you have everything set, so click finish. Now, before we do anything else, we need to lower this computational domain to be closer to our actual car. This box right here is our computational domain. This is a little bit bigger than our car, so we don't need this much computation. So click computational domain up here. Just scale this down to roughly the size of your car. It doesn't have to be perfect. Make sure you're scaling in every direction, including this way. You can lower that a little bit. And then once you're done, click OK. Now we need to set our global goals, what the simulation is trying to find, because we are concerned with the drag and force. So we want to go to global goals, scroll down, find force in the X, Y, and Z. So our lift is going to be in the Y direction, and our drag is going to be in the Z direction, like we said. So we want to check Z and Y. Click OK. Now you can see in the left over here, underneath goals, underneath flow sim, we have our force in the Y direction, which will be our lift. So go ahead and properties, right click on that, click properties, and then name this to lift so it's really easy to find later. Right click on this one, properties, and then do drag. So now we have those. Now we are ready to actually run the simulation of everything defined. So go ahead and click, this is uneven, but this is not going to change anything. Click run, and then click, before we click run, this is a little bit uneven. It won't hurt anything, but I'm going to right click on this, edit definition, and then just scale that a little bit so it's a little bit more even. Go ahead and click run once you have everything set up. This could take a little while depending on how good your computer is. If you have a potato computer, it could take a while, but you'll see down here that your flow simulation is going. Click on that to open the tab. You can see the iterations it took. It took 45 iterations for our drag and then 59 to calculate the lift. Okay, so go ahead and use the average value and not the current value, just because it gives you the best number, with the last value being a potential outlier. Now you want to close this tab. You want to minimize it because you will be using this later. You'll notice that our drag is -0.55. It should not be a negative value because a negative value does not make sense in our case. For a CO2 car, we don't want a negative drag. But because we set the wind in the negative Z direction, it was -20 miles an hour, 20 meters a second, it's going to be a negative number. So just know that that drag is actually a positive value. There is 0.55 newtons resisting our car moving down the track. And then our lift is negative. That is an actual negative value. So we have a down force of 0.177552 newtons pushing down on our car as it is going down the track. Some cars, depending on how they're designed and how you design the spoiler or the frontal wings, they could have a positive lift, and that is normal for your car. But just know, if you're wind speed was negative, your drag will also be negative, but it should always be a positive value in reality. So go ahead and minimize this tab so we can calculate the drag coefficient later, so we can keep those and find those easily. Now, what you want to do now is actually find the flow trajectories, which will be the visual indicator of where the air is flowing around your car. So to add your flow trajectories, which is the coolest part, go ahead and click Insert and then Flow Trajectories. And then what you want to do, click Control A on your keyboard to select all of the components of your car. And then click down here. Make sure you have arrow selected because that is the most helpful for a flow simulation. For flow trajectories, it'll allow you to see the most. You can select other ones. Spheres look like particles, which is kind of cool. But arrows actually gives you a direction. So click that, and you can change this later after you are done to get different visual flow trajectories. So once you have this, click OK. This can take a few minutes depending, again, on how good your computer is. If you have a potato computer, this could take 20 minutes, but for mine it should be around a couple minutes, so I'll speed this up until it's done. Okay, so once your flow simulation is completed, you should now see arrows around your car. Before we do anything else, we want to change the scaling of the arrows so that they are more understandable and we can differentiate between the pressures. So go ahead and hover over this until these turn orange, right click on it and then click edit. You want to change the values for the pressure between 115,000 and 120,000 should be good. And then go ahead and click OK. Now you should see that you should be able to differentiate between the high and low pressure areas. We have some red at the front of this car and then some blue around the wheels, which makes sense. And it's easy. Now you can change this a little bit if you're finding that all of your values look the same, but that should be good for most cars. Now we can go ahead and underneath results, click this plus right here, right click on this and then click play if you would like to, and you can actually see an animation of how the air is flowing. So you can see up here at the front, you can see how the air is flowing. So once you have this, if you would like to hide the computational domain, the gray box, because it's not extremely visually appealing, go ahead and scroll up, right click on computational domain, and then click hide. If you would also like to hide this kind of annoying origin down here, right click on flow sim, your flow simulation, and then click hide global coordinate system, and now you have just your car. You can click your spacebar, get your views, whatever, to get a nice visual result. You can stop this animation. You can also by right clicking on flow trajectories. You can also hide this as well. So that is how you run the flow simulation and get your values. So now I want to show you very fast how to calculate the drag coefficient of your car. So this will require a little bit more SolidWorks, so go ahead and hide your flow trajectories right here. Now click the spacebar to get the front area of your car. So drag coefficient is calculated using the equation that I'll put on the screen. It basically accounts how much drag force is resisting your car moving down the track, and then the front area of your car, how big it is, and then also we will take into account the speed at which your car was moving when those forces occurred. Because a brick moving at Mach 4 should have the same drag coefficient as a brick just dropped from a building, because it should take into account all of the different variables that were happening. So it's a good number for understanding the relative streamlinedness and aerodynamics of your car. And because the drag force isn't extremely helpful just on its own, I'll show you how to calculate that. So what you want to do is you need to get the front area of your car. So go ahead and click the sketch button. Now we need to sketch on the front plane. So click this arrow until you get back over to the assembly. Now select the plane that is the front area that the front of your car is aligned with, and then click the sketch button, and now you have started to sketch on the front plane. So what you want to do now is you want to click this button right here, convert entities, and then this little arrow, and then click silhouette entities. Now select the 3 components, the 2 front wheels and your car, and then click the green check mark. Now if we rotate this around, we can notice that we have an area of the car. So this we can evaluate using the evaluate tool and get a quick measurement of the area of our car. So unfortunately my SolidWorks defaults to IPS, and what we want to do for the spreadsheet is use millimeters. So go ahead and click down at the bottom of your screen, change this to millimeters if it's not. You can calculate the drag coefficient by hand, but for the spreadsheet ease of use, I will use millimeters. Now click the evaluate tab and then go to section properties right here with your sketch selected. Make sure your sketch is selected, and then you'll see this area value. So go ahead and copy that number, Control C, click Control C, and then click the X. Now that you have your area, go ahead and go to the spreadsheet and then paste that in. So I have the spreadsheet open right here. Now you go over this and then Control V to paste your car's area. And then you notice right here it's calculating the total area in meters squared now. It's a very small number, which is why we did it in millimeters so that you could easily see that. Now what you want to do is you have this flow simulation tab that we saved from before. Go ahead and use the absolute positive value of whatever your drag force was. So that's 0.55. Because we had a negative direction for our wind, our drag will be negative, but we know that it's supposed to be positive. So it's 0.55. So we'll type that in. And if you used a different velocity, then go ahead and change that. Don't change the air density unless if for some reason you change that. Now you have your drag coefficient, which is 0.57. Now the lift you don't have to put in here because you already found it. I just put that as a cell because you can see the lift of the example cars. Those were interesting cars because they had a positive lift. You have a negative lift for this simulation. Depending on how your car is designed, again, you could have a positive or negative. Your drag should be positive, but your lift could be negative. So that is how you evaluate it. And so that's all I have for you. If you have any questions, again, just put a comment down below and I will get back with you as soon as I see it. Good luck with the flow simulations and good engineering.